All right, hello class. This is Simple Machines video 1. Remember, you need to complete the notes. It needs to be in your notebook. It needs to be in your notebook. Okay. So the first question is, how do we go from force to energy? We haven't really talked about energy yet, but that's okay. Force is very related to energy, and all we do is we take the amount of force that we apply and we multiply it by how far the applied force moves the object, and that gives us energy. For example, we have the kitty, meow, right? The kitty is applying a force. The kitty is moving an object. The kitty is using energy. Okay, and what do we call this? We call this work. Okay, force times distance. So think about this. If the kitty uses a force of 1 Newton, an applied force of 1 Newton, to move the object a distance of 0.2 meters, let's say it's 0.2 meters, right, 20 centimeters or so, what we do is we multiply those two values together and we get 0.2 Newton meters. Well, a Newton meter is also known as a joule, and it's a measurement of energy. So that kitty just used 0.2 joules of energy to move the deodorant. Okay? Now, moving on to what is rate of energy. So imagine that I'm pushing something with a force of 5 newtons for 5 meters, and it takes me 5 seconds. Okay, how do we do this problem? This is a problem that we're going to have to be able to do. Okay, well, we know that the work would be 25 joules because we multiplied 5 newtons by 5 meters, right? Work is force times distance. Force times distance, 5 times 5, 25 joules. In power, well, we call power rate of energy, and the way we calculate power is work, 25 joules, divided by time, 5 seconds. Okay, we have 25 joules divided by 5 seconds. That gives you 5 watts. That's the measurement of power. That sounds familiar. Yes, it should sound familiar because that's how you measure your light bulbs, because the light bulbs give you power. Okay? So, last thing, what is elastic potential energy? I think most of us know that potential energy is stored energy. Okay, and when potential energy is released, it can create a force and it can do work. So maybe like a rubber band or a spring, like this. Potential energy is doing work, right? It's got potential energy, then eventually it turns into kinetic energy and it does work by crushing that watermelon. Or this one, mouse traps. Yeah, mouse traps can do work. All right, that's important to think about, and they have elastic potential energy. That is all for this video. Take notes and good luck.